All right, today we're going to complete the material for systems of equations by doing some word problems and some graphing. So I've picked 11 problems straight from the textbook, and I hope to do them. And in the process of doing them, I hope to show you a bunch of techniques. So I'll go in. All these are coming from section 5.4 of your textbook. So let me go ahead and paste the first one, which is problem number 2, in case you're trying to find out where they are in the book. And what we have here is that one number is half another number. So you can see there's two unknowns into play here. The sum of the two numbers is 141. Find the numbers. So what I could do is this. The numbers are x and y. So I want to figure out x and y, and then I can proceed. So let's start with the first part of this. One number is half another number. So that part, I don't know if I want to label this or not, but this one number is half another number. That part right there, we could say that x equals 1/2 y. It doesn't specify which number, and so it doesn't really matter here. And then the sum of the two numbers is 141. So let me put an equation for that. That one would be x plus y equals 141. So those are my two equations. So to solve this system of equations, I think the easiest thing to do is to take this first equation and plug it into the second equation using substitution. So the second equation, once I use this x equals 2y, I'm going to take that and plug it into that. So I'll get 1/2 y plus y equals 141. If I add those together, I get 3/2 y equals 141. And to solve for y, multiply both sides by the reciprocal of 3/2. So I'll multiply both sides by 2/3. And so those things in front of the y will cancel out. Over here on the right side, the 3 goes into 141 47 times. So I end up with 94. So I'll put that into the spot waiting for me for y. And now the x is 1/2 of y. So it's 1/2 times 94. We make that dot a little bit bigger. And that is 47. I'm just going to do a quick check of myself. Here, obviously, x is 1/2 of y. We just did that part of it. But the second part is, do they add up to 141? And if you do add these two numbers, they do, in fact, add up to 141. So those are our two numbers. Each of these is going to exploit something that you've already used, either substitution, the elimination method, or any of those other kinds of methods. They're all coming straight from the textbook, so let me go back and pick another number. I want to pick this time number 8. Every time I copy, my thing reminds me that I'm copying, but it's okay. Let's go ahead and make this bigger. And let's see what we have here. We have a hardware store, and it looks like they've sold the regular incandescent light bulbs and then the energy efficient compact fluorescent light bulbs. So how many of each type was sold if they sold a total of 279 of them? So let me write out first what the answer will look like. So they sold blank regular and blank CFL light bulbs. So this is the way that I would do it. Now, one thing you can do, since we're using more than one letter for these things, you can use X and Y and stick with those for every single problem. I find it more useful to pick letters that are indicative of what they stand for. So for example, under regular blank, I'll put an R. And under the CFL blank, I'll put a C. And instead of X and Y, I'll use R and C throughout the problem. So let me underline some important things here. They sold 27 fewer regular bulbs than, there's a lot here, than CFL bulbs. That's really all I need here. So they sold 27 fewer regular than incandescent bulbs. So what that means is the first equation is R plus 27. Or maybe better this. I think since the way it's stated is they sold 27 fewer, so I'm going to write it in that format. So this means that they sold 27 fewer regular bulbs than the C bulbs. Then there's a second piece of information here. It says how many of each type of bulb was sold if they sold a total of 79. So that part right there is crucial. And a total means I'm going to add them together. So I have R plus C equals 79. So hopefully you can see this is a very, very simple problem as far as setting the substitution here. I can directly place this R into the second equation. So the second equation, let me put it over here. The R is going to be replaced with C minus 27. There was my R from before. So you can see R disappeared, C minus 27 is in its place. So I get 2C minus 27 equals 79. Add 27 to both sides. I'll get 2C equals 106. And then divide by 2. And we see C is equal to 53. So let me put that here. And to get the number of regulars, we'll use this first equation that was already solved for R. R equals C minus 27. So R is equal to 26. So let's just make sure if all this works out. First of all, do they add up to 79? 26 and 53, that is 79. And we just did that R was 27 less than the C. So we've covered all our bases and our problem is finished. For our next one, I want to grab number 12 out of the book. These are what they call geometry problems. Each one of these sort of has a subtitle for what they are. And geometry problems usually involve triangles or rectangles or circles or squares or something like that. This one I see does nothing but a rectangle. And let me increase the size of this. Alright, so we have the length of a rectangle is 3.5 inches more than its width. When they say find the dimensions of the rectangle, they mean find the length and find the width. So we could say the length is, and the units they're using are inches. So let me put blank inches. And the width is blank inches. So for me, like I said, I'm going to use letters that are indicative of what they stand for. So I'm going to use an L for length and a W for width. Now let's write down some of the equations that we have. First equation comes from this line. The length of a rectangle is 3.5 inches more than the width. So we can write that as L is 3.5 more than the width. Now the next thing we're given is that the perimeter is 23 inches. So the perimeter, the perimeter means we add up all the sides, 2L plus 2W, and that's equal to 23. So the perimeter, this says the perimeter is equal to 23 inches. So what I'm going to do is the same thing I did in the last problem. I'm going to take this 3.5 plus W, and I'm going to put it in where it says L there. So let me show you what happens to the second equation. Insert it with parentheses so that you'll remember to distribute the 2. And you know things are right because now you only have one letter to solve for instead of 2. Let me multiply through by the 2. So we get 7 plus 4W equals 23. I'll subtract the 7, so 4W equals 16. Divide by 4. Looks like W equals 4 inches. And then L is 3.5 inches more than that. So it looks like for L we get 7.5. Let's just make sure that everything works out. The second part, 3.5 more, is simple. We just did that part. But is the perimeter actually 23 inches? Well, let's add up all the sides. If I have L is 7.5, then twice that is 15. So I have 15 so far. W is 4, then twice that is 8. So 15 plus 8 is in fact 23, and we've solved the problem. Let me grab number 18 out of the homework. I think 18 is another problem like that. Geometry problem. All right, we need to find the measures of the angles x and y if y is 2/3 the measure of x. So I really don't, there's not much here to do. I'll just say that x equals blank degrees, y equals blank degrees, and they've given you the measure of y is 2/3 the measure of x. So we have y is 2/3 of x. Now the second equation, where does that come from? Well, it comes from the triangle itself. You must know that if you add up all the angles, then you'll have 180 degrees. So from the triangle itself, we get the second equation, x plus y plus 75 equals 180. And now let me change things up a little bit. Here, I'll keep y equals 2/3 x. Well, actually, you know what? I think what I'm going to do is I can directly substitute this 2/3 in for y right now. So let me do that. So the second equation becomes x plus 2/3 x plus 75 equals 180. So you can see that the y was substituted in for, and that's where that 2/3 comes from. I can add the x's together to get 5/3 x equals, at the same time, I'm going to subtract 75. Now in order to figure out what x is, I'll multiply both sides by 3/5. So that cancels those numbers. 5 does go into 105 21 times. So x is equal to 63 degrees. And then y was equal to 2/3 of that amount. It's actually the same kind of deal. I can cancel the 3 and I get a 21 again. So that's 42. So x is 63 degrees and y is 42 degrees. I just want to make sure everything adds up and works out right. If I add the two of them together, I do get 105 degrees like it said, and I just did the computation for one being 2/3 of the other. So that was not a problem indeed, and we're finished with this problem. Next up, I want to grab problem number 22 from the textbook. And this has, your book calls them problems involving cost. All right. What we have in this problem here is that Manny and Hiroki buy two types of tickets. They buy left field pavilion seats and club seats. Each one of them buys a collection of them, and they want to know the cost of each type of ticket. So let's do this. The left field tickets cost blank dollars each, and the club tickets cost blank dollars each. What I'm going to do is I'm going to let C stand for the club tickets, and I am going to let L stand for the left field tickets. So let's see what they did here. Manny buys 3 left field seats and 6 club seats for $291. So that line tells me that I have 3L plus 6C equals 291. Next, it tells me that Hiroki spent $292 on 8 left field seats and 5 club seats. So 8 left field and 5 club was $292. Now this is the type of method that's probably best here, or at least the one I'm going to do, is elimination. And the first thing I'm going to do is target L for elimination. So let me start with that. So what I'm going to do is, if I multiply the first one by 8, I'll have 24L. If I multiply the second one by 3, I'll have also 24L. And I'll probably do -3 on the second one, so that one's 24L and the other is -24L. So for the first equation, I'll multiply it by 8. And then the second one, I'll multiply by -3. So let's see what this gives us. When I do the 8 through, I'll have 24L plus 48C equals, let's see here, 2328. And for the second one, I'll get -24L minus 15C, and that one will equal -876. So when I add these two things together, I'll get 33C is equal to 1452. Obviously, the thing to do is to divide by 33, and we get C is equal to 44. So each club ticket cost $44. Now to go and find the value of L. So this time I will target C for elimination. This time I want to take out the C's. So if I multiply the first equation by 5, I'll get a 30C. If I multiply the second equation by negative 6, I'll also get a 30C, but it'll be negative, and they'll cancel. So the first equation gets multiplied by 5. And the second equation is multiplied by negative 6. And let's see what we got there. I have 15L plus 30C. That equals 1,455. Then for the second one, I get negative 48L minus 30C equals negative 1,752. Let's add these together. Negative 33L equals negative 297. So I'll divide by negative 33. And it looks like I end up with L is equal to 9. So the answer for the second part is $9 each. Next, let me grab number 28. Here is a mixture problem. All right, so for this one it says we are going to be mixing a 15% acid solution with a 3% acid solution, and we want to get 45 milliliters of a 7% solution. So it says how many milliliters of a 15% acid and how many milliliters of a 3% acid. So we'll say something like use blank milliliters of the 15% solution and blank milliliters of the 3% solution. I don't see, in this problem here, there's nothing that gives me a good indication to use any letters because nothing is specifically outlined where the first letter would be meaningful. So what I'll do is I'll just let X be the amount of the 15%, and I'll let Y be the amount of the 3%. So the first thing that we do, how many milliliters of a 15% acid? So what we're doing is we're taking a 15% solution, multiplying it by X. That's how much acid is in the 15. That's how much pure acid we're using of the 15%. And then we're using Y milliliters of the 3% for a total of 45 milliliters that is 7%. So 7% times 45. On the other hand, we know that we're using a total of 45 milliliters. That means that X plus Y must equal 45. That's the total amount of liquid that we're using. So now let me change these to equations that are more meaningful to us. The first equation becomes 0.15x plus 0.03y equals 0.07 times 45. The second equation is just x plus y equals 45. And let me do one more version of this. 0.15x plus 0.03y equals 3.15, and x plus y is 45. Well, I think such a problem like this, it's very simple to do by substitution. I can take this second equation and solve for either letter that I want, and then plug it back into the other equation. So for this second part, I might say that x equals 45 minus y. And then when I plug it into the first equation, I'll replace x by that. So I'm going to take that x and plug it in to that spot right there. So I'll get 0.15 times 45 minus y. You see it? 0.15 times x. There's my x. Plus 0.03y equals 3.15. And now let me go ahead and multiply these things through. When I do the 0.15 times 45, I end up with 6.75 minus 0.15y plus 0.03y equals 3.15. Let me combine my y's together, and I'll get 6.75 minus 0.12y equals 3.15. Let me subtract 6.75 from each side. So we'll get negative 0.12y equals 3.15 minus 6.75 is negative 3.6. And so I can divide by negative 0.12, and it looks like I'll get 30 for y. So y was the amount of the 3%. We're going to use 30 of those. But now from my second equation up here, I can easily get x. X equals 45 minus 30, and so we need 15 milliliters for that. Now what I would do is I would plug them back in and make sure that they still work out. I think this is the equation we want them to work out for. So for example, if I throw in the 15 for x, I'll get, 2.25 for this? And then if I throw in the 30 for y, I'll get 3 times 30 is, that looks like 9. 0.9? Well, let's make sure about it. So let me check. We're going to do 0.15 times 15 plus 0.03 times 30, and that's supposed to equal 3.15. When I do 15 times 0.15, I'll get 2.25 for that part, and then I'll get, let's see, that'll be 90, take 2 decimals, so 0.9 for that part. And certainly that works out. My next one that I want to grab from the book is number 32. This is also a mixture type of a problem, although it doesn't involve liquid. It involves something that you typically find in a grocery store. Everybody probably has bought those packages of various types of nuts, peanuts and cashews and things like that. And you know that cashews sell for a lot, but peanuts sell for very little. All right, this time we're doing a mixture of peanuts and cashews, as I said. how many pounds of peanuts and how many pounds of cashews. So we need blank pounds of peanuts and blank pounds of cashews. For me, it's clear I'll use P for peanuts, C for cashews. And let's see what we have here. How many pounds of peanuts that sell for $1.80 a pound should be mixed with cashews that sell for $4.50 a pound, and a 10-pound mixture, so that a 10-pound mixture is obtained that will sell for $2.61 a pound. So cashews sell for $4.50 a pound and peanuts are $1.80 a pound. And we want a 10-pound mixture out of the deal. So we want, on the one hand, we're going to want X pound, well, not X, I told you P and C, but we want P pounds of peanuts, but they sell for $1.80 per pound. And added to that, we have $4.5 per pound times cashews. And we know it's 10 pounds, and it's supposed to sell for $2.61 a pound. So there's one of my equations. So that was all the stuff that was in the first part. But this part right here, the 10-pound mixture, that tells us that the amount of peanuts plus the amount of cashews is 10 pounds. And so now I'm ready to go ahead and solve these equations. My first equation is 1.8p plus 4.5c equals 26.1. And the second one is p plus c equals 10. Once again, I think the easiest thing to do is substitution. The second equation I will solve for, it doesn't matter to me, c equals 10 minus p. And I'll take that quantity there and plug it into that spot there. So I will get 1.8p plus 4.5 times 10 minus p. That's equal to 26.1. So I get 1.8p plus 45 minus 4.5p equals 26.1. Combining like terms, I get negative 2.7p plus 45 equals 26.1. I'll subtract 45 from each side. And it looks like negative 2.7p equals, it looks like negative 18.9. So divide by the negative 2.7, divide by negative 2.7, and it looks like, what do I get? 7? Yes, p equals 7. So I can fill in that spot. And then the c is 10 minus that. So for the amount of cashews, I get 3. Let me go ahead and copy number 36 in. I'm trying to do all the types of problems we've done. You've actually seen every type of problem like this before. When we were doing it with just one letter, you kind of had to do the same thing for the most part. Go ahead and bring this in. So let's see, we have Marique. I'm not sure how to say the name, so I'll just say Marique inherited 15 grand, and she's splitting it into two accounts. One earns 5%, one earns 4%. And she earned a total of $660 in interest. So from right here, we're going to get an equation. And also, from the total amount, we're going to get an equation. But let me write the answer the way it will probably look. So let's see, Marieke let's say she put blank dollars into the 4% account and blank dollars into the 5% account. And once again, I don't see anything better than X and Y for this. Nothing is grabbing me as being useful in describing the quantity that it signifies. So I'll just go with X and Y. So what we have is, first, she earns $660 in interest. So for the X dollars, we take the interest rate, 5% times X dollars, plus 4%. Actually, what did I do here? X is the 4%. Oh, let me change it then. So 4% times X plus 5% times Y. This is the total amount of interest that was earned, is 660. So you take the amount times the interest. We're talking about 1 year, so we don't have to get involved with that interest formula. Secondly, she inherited $15,000, so we know that X plus Y equals 15,000. Once again, to me, this looks very much like a substitution kind of a problem. I'll have X equals 15,000 minus Y, and I'll plug that into the first equation, into that slot there. So also let me at the same time convert to decimals. So I have 0.04x. There's my new version of x. Plus 0.05y, which I can just leave itself at y. And that's equal to $660. Now if you look, when we did these problems earlier in the semester, remember we would do this kind of stuff to avoid using two variables? Well, this is exactly what we did in our first step. So this using two equations helps us out with that portion of it. And so let me go ahead and multiply these things through and see what we get. So I will have 15,000 times 0.04. I think that's going to be 600 minus 0.04y plus 0.05y will equal 660. I'll combine the y's. I'll get 600 plus 0.01y will equal 660. I'll subtract the 600. That'll be 60. And then I'll divide by 0.01, which has the effect of multiplying it by 100. So y will be 6,000. So she put $6,000 into the 5% account, and then into the 4% we can use the 15,000 minus y equation. So x equals 15,000 minus 6,000. And so the amount in the 4% account is 9,000. Now, none of this, as you know, would be complete unless we did some of those problems involving trains. So let me get one of them out. I'll grab number 40 from the textbook. And let's see what we have. We have two types of trains. we have a freight train and a passenger train, 400 miles apart, traveling toward each other. And we know the passenger train is traveling 16 miles per hour faster than the freight train. So find the speed of each. So what I'll do is I'll say the speed of the passenger train travels at blank miles per hour, and the freight train travels at blank miles per hour. Here I do have a difference between the way they're said. So passenger, I'll put a P. Freight, I'll put an F. All right, let's set this up here. Let's look at the passenger train versus the freight train. And we use the formula distance equals rate times time is the basic formula for these things. Let's see what these numbers are, or what numbers we can put in. Or right now, for the passenger train, I'm putting P and then F for the freight train. Those are the two things we're trying to find. I do know that the time is 5 hours, right? And what else do I know? That the total distance that they covered between the two of them was 400 miles. So total distance equals 400 miles. So what is the total distance? Well, the distance traveled by the passenger train is P miles an hour times 5 hours, plus the freight train travels at F miles an hour times 5 hours, and we know that together they cover 400 miles. On the other hand, I am told that the passenger train travels 15 miles an hour faster than the freight train. So to me, it seems very obvious that you're going to use substitution. I'm going to take this quantity here and plug it into that P there. So my equation turns to this. I'll put the 5 in front just because it makes me feel more comfortable. 15 plus F. And then I have 5F equals 400. Let me multiply through by the 5. I get 75 plus 5F plus 5F equals 400. Let me subtract the 75. I think I made a mistake there. It was 16 miles per hour faster. So let me see if I can fix that and make it into a 6. Make that into a 6. And that changes this number to 80. So we have 80 plus 10F is 400. Subtract 80 and I'll get 10F equals 320. Divide by 10 and I get F is equal to 32. On the other hand, P equals 16 plus F. So P is 48. And then to check them, you could look at them, they're traveling toward each other at a combined rate of 80 miles per hour. 80 miles per hour times 5 hours is indeed 400 miles. And I think, let me see how many more problems I wanted to do here. Still 3 more. Let's do number 46 next out of the textbook. More motion problems, although these are a very specific kind of motion problem, and I'll explain it in a minute here. You're told information you may not be aware of, and to the book, they've done examples in this, but it's trying to trying to illustrate to you in the most simple terms what it all means. It's a travel problem. So we have a boat that is going upstream and downstream. Downstream, the boat can go faster even though it's not trying as hard, just because the current will speed it along. Going upstream is harder because you're fighting the current. So let me make you aware of a couple things. Let's say I have a river, and we have the current is going like this. And let's look at a boat on that current. This is my version of a boat right here. Okay, so that boat is trying to go, when it goes downstream, it actually looks like a fish, doesn't it? I don't know if I can make it look more boat-like or not, but whatever. So it's a fish, I don't care. Anyways, the speed going downstream, so let me do this, downstream. The speed is, we have the speed of the boat not the boat, the boat, plus the speed of the current. That's how fast it's going to be going downstream. Now, on the other hand, going the opposite direction, here I'll see if I can draw a better boat, but I doubt it. This time, going upstream looks like this. So, and the boat wants to go against, it fights against that speed. So, upstream, the upstream speed is still the speed of the boat, but now it's minus the speed of the current. So this time the current takes away from your speed. So let me show you let me draw a diagram, not a diagram, but let me draw a chart of what's going on here. We've got two things we're doing. We're going downstream and we're going upstream. Downstream is faster than upstream. And let me put our usual things. Distance equals rate times time. And we'll fill out what we can in this table. So let's see what the information is here. 15 miles downstream. It takes them 0.75 of an hour. And they don't list the rate. So I'll tell you what I'm going to do for downstream. We're just going to be calling it, actually I don't want to call it that. I'll call it something else. Upstream, they can go 9 miles in the same time. So what I want to do is the speed of the boat is blank miles per hour, and the speed of the current is blank miles per hour. So if I call the speed of the boat by the letter B and the speed of the current by the letter C, then here's what we got going on. Downstream, you have the boat speed, but you can add on the current speed. Upstream, you can subtract the speed of the current from the boat. And there's how we set up our equations. So the D equals RT gives us an equation. Let me write this one down. D equals RT tells me that 15 equals B plus C times 0.75. That literally is rate times time. In the second equation, we get 9 equals B minus C times 0.75. So those are our two equations. Let me bring them down below. and I'll get my 15 equals B plus C times 0.75. And then the second equation, I'll have 9 equals B minus C times 0.75. This next step may seem unusual, but I think it makes things so much easier. I'm going to divide the first equation by 0.75 and the second equation by 0.75. And that will give us then 20 will equal B plus C. On the second equation, I'm going to do the same thing. Divide by 0.75, divide by 0.75, and that second equation then will give us 12 equals B minus C. So those are the two equations that I'm actually going to work with. B plus C equals 20, B minus C equals 12. I think anybody can see at this point that the best thing to do, or I don't want to be quite that clear about it, but to me it seems really simple to add them together. You get 2b is equal to 32. Divide by 2, and you get b is equal to 16. Then, this is sort of a combo thing, I'm going to put that 16 in one of the first equations, probably put it into the first equation. So b plus c is equal to how much? 20? If I replace b with 16, I'll get c is equal to 4. And I always like to make sure that it does work out that way. If I add them together, that's 20 miles per hour. 20 times 0.75 is indeed 15. If I subtract them, 16 minus 4 is 12. 12 times 0.75 is in fact 9. So they check out. Next, I want to grab number 48. Same type of a problem exactly, but maybe you can pause the video and see if you can solve it yourself before I actually go ahead and do it. So what we have here is a boat can travel 12 miles downstream in a certain amount of time and 3 hours to go upstream. And we want the same thing. We want to find the speed of the boat in still water and the speed of the current. So the speed of the boat is blank miles per hour, and I'll put a B underneath of that. And the speed of the current is blank miles per hour, and I'll put a C under there. So let me go ahead and set up a table just like I did before. We're going to be doing upstream versus downstream. And we'll be basically using the formula distance equals rate times time. Do I know any of these quantities yet? I know that going downstream, I could go 12 miles in 1.5 hours. And we know that that was downstream, 12, 1.5. To go upstream, it takes 3 hours to travel the same distance. 12 is the same. So remember, downstream is B minus, upstream is B minus C. Downstream is B plus C. So let's set up my two equations. The first one gives us 12 equals B minus C times 3. And the second one gives us 12 equals b plus c times 1.5. I'm going to do like I did before, and the first equation I'm going to divide by 3, so I get 4 equal to b minus c. In the second equation, I'm going to divide by 1.5, and I'll get 8 equals b plus c. So my two equations look like this. I have b plus c equals 8, b minus c equals 4. Add them together, I'll get 2b equals 12. Divide by 2, and then I get b is equal to 6. On the other hand, I can use either of these equations now. I'll use the first equation, b plus c equals 8, now that I know that b is equal to 6. So c is equal to 2. And I'll just check. Let's just see here. When they're going against the current, I have an effective rate of 4 miles per hour. 4 miles per hour times 3 hours gives me 12, so that's right. When I effectively add them together, I get 8 miles per hour times 1.5 hours does give me 12 miles. So it all does work out. And the last problem I wanted to do was problem number 50. So excuse the children in the background, they are feral. All right, let's see what we have here. All right, let's see what we have in this situation here. We have 2 hours for a plane to travel. Well, this is the same type of a problem. If you're going with the wind and against the wind, it's just like going with the current and against the current. Wind is air current. That's exactly what it is. So we'll do with wind and against wind. You might find that sometimes as you're traveling across the country that it takes you a couple hours to go longer one way than the other way. It's because of wind. I didn't write my answer like I normally do, so let's do this. The speed of the plane is blank miles per hour. So I'll put a P under there. And the speed of the wind is blank miles per hour, and you might have guessed I'll put a W under there. So we have to do these two things, with wind and against wind. So let me go ahead and set up my chart like I normally do. So I'll do with the wind and against the wind. And what do we have for these two things? I'm going to use the same formula because it's a motion problem. Distance is equal to rate times time. And let's see what we have now. It takes 2 hours for a small plane to go 390 miles with the wind. So 2 hours, 390. And we know that with the wind, you're helped. So I'll put a P plus W. That's just like the boat in the current. Against the wind, it can go 330 miles, the same amount of time, but its speed will effectively be P minus W. So the equations I get 390 equals P plus W times 2, and then 330 equals P minus W times 2. I'm going to divide each of these equations by 2 so that you'll understand where I get the next step. The first equation becomes 195 equals P plus W. The second equation becomes 165 equals P minus W. let me add these two things together. When I add them together, it looks like I get 360 equals 2p. Divide by 2 and I get 180 equals p. So I can put that into this spot. Next, how do I get the wind speed? Well, I think I'll use the first equation here. I have 195 equals p, so 180 plus w, and so it looks like 15 will equal w. Let's see if these things make sense. W equals w, 15. Let's take a look. When they're with the wind, he's going 195 miles an hour. 195 times 2 is in fact 330. When he's going against the wind, you're doing 180 minus 15 is 165. 165 times 2 is indeed 330.